Hey fam, it's your boy, Mr. Wishart, coming back at it again. Talking about exponent properties. All right, so the idea is we're going to talk about some properties of exponents. We're not going to talk about, we might mention negative exponents a little bit because we've got a few problems with it. But we're also not going to talk about the zero exponent property. This will be product, quotient, and power. It's got some vocabulary, right? We've got base, exponent, coefficient, produce, quotient, and power. When we look at a problem like this, the big number, or variable, is the base, and the small number is the exponent. Okay, if you have a number out front, that's the coefficient. So it covers the first three right there. Okay, so when you have a situation like this, where you have the same base, so x's, you have different exponents, and you're multiplying them, this is what you do, right? I think it makes sense, at the beginning of this at least, to kind of expand this, put this in expanded form. 3, 4, 5. Because what this x cubed means is that you have three x's that are multiplied together. And this x5 similarly just means that you have 5 x's multiplied together, right? So now what we do is we just kind of count them up, and we see that we've got 1, 2, 3, 4, 5, 6, 7, 8 here. So that's how we simplify it right there, right? Another way to think about this, rather than putting it in expanded form, is that we should realize that we just add the exponents. So this becomes x to the 3 plus 5, which is the same thing as x to the power of 8. Okay. So what do? Our base here stayed the same. It didn't change, right? So when you have your base, it stays the same. Okay, and your exponent, you added them together. Okay. Now, it changes the, I don't know, it doesn't change really, but we have coefficients in this one right here. So the idea with this is, since they're just regular numbers kind of out front, all you do, rather than like doing weird things like adding when you multiply, is you just multiply them together, right? So we have this 2 times 6 out here, and then I've got 7 y's here. 1, 2, 3, 4, 5, 6, 7. I think it is useful at the beginning when we start talking about this stuff to write it out in expanded form, but once you get used to it, you should realize that you can just show your work like this, right, as a more simplified way. But let me make sure I've got 7 y's. 1, 2, 3. Yep, okay, so 2 times 6 is going to give you 12. And then I've got 10 y's here. So I just do it like that. Right? If I were to put it in kind of a more simplified form, it would be 2 times 6 and then y to the 7 plus 3, which gives us the same thing, of course. Okay. So when you have coefficients, you just multiply them together. So this is how we kind of just handle all aspects of these problems, right? As your coefficients, your bases, and your exponents. That's how you deal with them, right? So you can have bases that are regular numbers rather than variables. Don't get confused and assume that these are coefficients, and so you think you might need to multiply them together. But these are not coefficients here. These are bases. So rather than just putting 5 x's or whatever, we would put 5 4's. And then another 2, and that's going to give us 4 to the power of 7. Right, again, it's 4 to the power of 5 plus 2, which is 4 to the power of 7. Right, again, 2 different ways to think about this. It also works when you have negative exponents. Actually, I'm going to show the kind of like shortcut first, because I think it makes more sense to do that. So 7 plus negative 3 is going to give you x to the power of 4. Okay. Now, when you like put this in expanded form, it gets a little weird, right? So let's kind of show it as x to the power of negative 1 times x to the power of negative 1 and x to the power of negative 1. Now, we've talked about how to deal with negative exponents before. The idea is that you kind of switch them to the bottom of the fraction, make the exponent positive, and make sure you leave a 1 on top, right? So this becomes basically 1 over x cubed, right? But we can write it as 1 over x times 1 over x times 1 over x as well, right? Now what happens is we have this x here and this being multiplied by this 1 over x. They're going to cancel out. And it leaves us with 4 x's, or x to the 4th right there, okay? So that's kind of how you approach product property. Quotient property is very similar, except it's the opposites, right? Hopefully by now we realize that a division problem is just a fraction problem. So I'm going to put a big fraction bar here. I'm going to put 8 x's on top, and I'm going to put 5 x's on the bottom. 5. And the idea here is that you should realize that anything divided by itself is going to be 1. So x divided by x is 1. X divided by x is 1. And you can basically match up x's on the top with x's on the bottom and get rid of them. So that leaves us with x cubed on top. Again, you think about it as x to the 8 minus 5 is going to give you that. So same base, different exponents. We are dividing. This is what we do, right? So the base is going to stay the same. But your exponents are going to be subtracted. Okay. When you have coefficients, it's going to be similar, but you're just going to divide them rather than multiply. So we're going to end up with 9 on top, 3 on the bottom, 6 c's, 3, 4, 5, 6, and then 5 c's, 2, 3, 4, 5. Those cancel. We end up with 9/3 c, which is the same as 3c. Okay. You can also approach it as 9 divided by 3 with c to the power of 6 minus 5, which is 3c. Technically 3c to the power of 1, but you don't need to write that invisible 1 for the exponent. So when you have coefficients, you just divide them. Okay. Just like that. Now, this is actually really similar to the first one. It's just shown in a different way, right? So you can see problems presented like this with the division symbol, or you can see problems presented like this with the fraction bar. It's the exact same thing, right? Because a fraction is just a division problem, and a division problem is just a fraction, right? It's the exact same thing. So 1, 2, 3, 4, 5, 6, 7, 8, and then 3 on the bottom. And we just cancel them out. We get x to the 5th. That's a terrible 5, but that's a 5. Shortcut would be just be 8. X to the 8 minus 3, x to the 5th. Okay. It's also a terrible 5. Why are my 5s so bad? Okay. Now when we get here, we have a smaller number on top and a bigger number on the bottom. So you got to, I don't know, let's just do it and talk about it as we go. Y times y. That's a bad y. 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So we end up crossing all these out, and we're left with 2 y's on the bottom and 1 on top, because y divided by y is 1, right? So that y is left on top, and then you have 2 y's on the bottom. So this is 1 over y squared. If you were to do the shortcut, this would be y to the power of 7 minus 9, which is y to the negative 2. Okay, this calls back to this problem right here, where we had this negative exponent, and the idea with the negative exponent is it just moves the base and the exponent to the bottom of the fraction and makes it positive. This is technically what's happening right here. You have those left on the bottom after you divide, right? So that's why this is equivalent to this, right? But in your final answer, you want to write it as a positive exponent rather than as a negative exponent, because in your answer you want to make sure that you have no negative exponents. Okay. I think I'm going to have to pause right there. I'll stitch it together in the edit later. Oh, of course. Hey guys, it's me, your math teacher, coming back at you again with another fire math video. Never mind. All right, we're talking about the power property here. This is when you take a power to another power. And so the idea here is that we can think of this as 5 groups of x squared, right? So I've got x squared here. X squared, same thing as x times x. I got another one right here. Hopefully we can see the yellow. And then I got the third group of x squared, or x times x here. And then the last group, right? And so when we write it out all like this, we can see that we have x to the power of 10. The shorthand way of doing this would be x to the power of 2 times 5, which is x to the power of 10. Okay, so the idea, how do we evaluate these things? Your base is going to stay the same, just like in pretty much all these. And your exponents will be multiplied together. Now, when you have coefficients, it's kind of like distribution. You just got to apply this 3 to both terms inside. Now, technically, there's an invisible 1, right, by that little 2 right there, okay, as your exponent. So if we write this out, we could say that this becomes, well, actually, let's expand it like this first. I'm going to have 3 2's multiplied together, and then I'm going to have 3 groups of 4 y's. Times y, 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 times y. Okay. Now we can see, let's use a different color. Let's use green. The 2 times 2 is 8, and that we have 12 y's. Count them out. 4 times 3, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Another way to think about this is this becomes 2 to the power of 1 times 3, and then y to the power of 4 times 3, which again is 2 to the power of 3, which is 8, y to the power of 12. Okay. So when you deal with coefficients, right, you apply the exponent to the coefficient. You just got to remember to do that, because the coefficient is separate from the base. Okay. Now, when we have a base that is 4 rather than a base that is an exponent, or sorry, a base that is variable, it's the exact same thing. You're going to have, gosh, I don't want to write out 21 4's, so we're just going to do 4 to the power of 7 times 3, which is 4 to the power of 21. You have 3 groups of 7 4's, and that's going to be it. Okay, now, similarly here, this 3, this coefficient is going to have an exponent of 1 that's invisible, just like we did here. And this 2 is going to apply to everything here. So it's going to be 3 to the power of 1 times 2, x to the power of 2 times 2, y to the power of 3 times 2, and z to the power of 7 times 2. 3 to the power of 2 is going to be 9, x to the 4th, y to the 6th, z to the 14th. Just like that. All right, move on to a quick word problem. And then, yeah, we'll be good to go. So the average weight of a newborn male caribou is 2 cubed pounds, 2 to the power of 3. On average, an adult male caribou weighs up to 2 to the power of 6 times more than a newborn. How can you determine the average weight of an adult male caribou? I like highlighting the numbers, underlining the question, and circling the important information in word problems like this, right? So you know we have 2 cubed right here. Times more means that we're going to be multiplying by that right there. So we're going to like break this out. Oh, it should be 2 times 2 times 2, and then 2, 3, 4, 5, 6 right there. Count it out, we're going to get 9, 2 to the power of 9. That's the same thing as 2 to the power of 3 plus 6. Now 2 to the power of 9 is going to be, I think 512 is what it works out to be. But let's just have the calculator do the math for us. We want the scientific calculator. So we can say 2 times 2 times 2 times 2, 4, 5, 6, 7, 8, 9.
Question, sir.
Sure, Mr. Savorn, how you doing?
Ready for a question.
Yeah.
I ask you because I respect your opinion.
Yeah, what's up?
Did you call out sick?
I did not. I got too much math to teach.
I did not call out sick either. I just wanted your opinion. Okay.
I mean, if it happens, it happens.
Yeah. I
Yeah.
did not do it. So. Okay.
I mean, my kids are here too, so like if they're here,
I
I
hadn't
might as well
thought
bring
about
them. Yeah, so
And for me,
we are being recorded, Just so you know,
Okay.
I'm
Oh, that's
recording a
fine.
video, so.
That's fine. For me, I guess I'm also old school.
Yeah.
And that's hard to change.
Yeah.
You know.
Yeah.
Okay. Hey, have a good night.
See you, man. So we figure out that 2 to the power of 9 is 512 pounds. So an adult male caribou weighs 512 pounds. On average. On average, 512 pounds. Okay, real quick, we'll do the spiral review for Pythagorean theorem. I'll get rid of the calculator here. We're testing to see if this is a right triangle. I'm going to say that is A, B, and C. This becomes 6 squared plus 8 squared equals 12 squared. When you have 3 sides, you plug them all in, and if it makes a true statement, it's a right triangle. And if it doesn't, it's not a right triangle. 6 times 6 is 36, 8 times 8 is 64, 12 times 12 is 144. Add those together to get to 100, and we can see that this is not a true statement, so this is not a right triangle. Look at that, oh my gosh. So much fun. Math is great, isn't it? Okay, there you go.